This lesson is for Advanced Algebra 2.5, the graph of y equals kx squared. The graph of y equals kx squared is a parabola with the vertex at the origin, also containing the point 1, k. Depending upon your value of k, the shape that the graph makes will either be a parabola that opens up, if the k is positive, or a parabola that opens down if the k is negative. So keep in mind here that the equation itself is called a quadratic. And it's the shape of the graph that's referred to as a parabola. So both of these graphs are called parabolas, but they come from a quadratic equation. Keep in mind that when the k is positive, it's going to open up, and the minimum point is referred to as the vertex of the parabola. When the k is negative, it will open down, and the vertex now is referred to as a maximum point. Notice that both of the vertexes in both situations are at the origin, which is the point 0, 0, but that the designation of being a min or a max depends upon the k value. Let's also talk about the domain and the range of these graphs. When you're looking at the domain of something, you want to think about what kinds of x values can be substituted into the equation. So you want to think about what x's can be squared. And pretty much any number you can think of can be squared. So the domain for both of these situations is all real numbers. And remember that you could also list that as capital R with a double bar. That's another way of saying all reals. For the range, you want to pay attention to what your k value is. If the k is positive, then the lowest that the graph gets is to that vertex point, and then it's everything above that. So the range could be y is greater than or equal to 0, or you could say positive reals. Or if the graph is pointing downwards, then you would say y is less than or equal to 0, or you could say negative reals. So that's the domain and the range of each parabola. Keep in mind that parabolas do not have a constant slope. Typically you can calculate the rate of change on a parabola, but you wouldn't refer to it as the slope. When you pick 2 points on a parabola and calculate the rate of change between those, you get a different value than if you picked 2 other coordinates later on. So we can calculate rate of change, but it will be a different number as you move along the parabola. Parabolas do have symmetry. They have what we call vertical symmetry, or sometimes called even symmetry. And all that means is if you fold it vertically, both of the branches of the parabola will line up with itself. And so we say that the symmetry line is the y-axis. The equation for the y-axis is x equals 0. So you could say that the symmetry line is on the y-axis or on x equals 0. So we're going to look at parabolas a little bit more in depth here with question number 6. In the homework it asks what happens to a parabola as the k value increases from 1 to 10. So we're just going to graph y equals 1x squared, 5x squared, and 10x squared, and we're going to see what happens to those graphs. Now keep in mind that when you graph those, let's talk about the other point that is made up at the top here. All parabolas have the point 1, k in them, because if you fill in a 1 for x, for example into this equation here, 1 squared is 1, times 1 is going to be 1. So this is going to have the coordinate 1, 1 in it. The next equation of 5x squared is going to have the point 1, 5 in it. 1 squared is 1, times 5 is 5. And then same thing for our last equation here, y equals 10x squared. You plug in a 1 for x. 1 squared is 1, times 10 is 10. So all of those parabolas have this as their next coordinate from the vertex. So let's do a quick sketch of that. So if I'm graphing my parabola, they're all going to have that vertex at 0, 0. The graph of 1x squared is going to have its next coordinate at 1, 1. Keep in mind that parabolas are symmetric, so its mirror image is going to be right over here. So that first parabola of 1x squared is going to look like that. Next equation of 5x squared is going to start at 0, 0. The next coordinate is going to be over at 1, 5. And then its mirror image. So that parabola, notice that it is skinnier than the previous. So we can kind of predict now what's going to happen to 10x squared. We can predict that that's going to be even more skinny because the next coordinate is going to be at 1, 10. And so let's describe now what happens. What happens to the parabola as k increases? It gets more narrow, or you can say more skinny, or any other word that would describe that in your own words. More narrow. So what do you think is going to happen as k decreases from 1 to 0? Another option for you is to try graphing that on your graphing calculator. So try typing in 1x squared. Let's try maybe 0.5x squared. We wouldn't want to do 0x squared because that would be nothing. So maybe we'll do 0.1x squared. So try typing those in. I think I did both of those, and I'll show you my results down below. So I've got 1x squared and 0.5x squared. And it looks like the first one is on the interior and the second one is on the exterior. So as the x is decreasing, the parabola is getting wider. So let's describe that. What happens to the parabola as k decreases? It gets more wide, or more spread out would be another way to say that.